Problem number 1. X to the negative 6 times x to the third. Now we remember that we had several rules that we learned back at the beginning of this unit. The rule that we're going to apply to this particular problem is our product rule, which tells us when we have the same base, we can simply add the powers. So we'll end up with x to the negative 6 plus 3. So still keep the base. Negative 6 plus 3 is negative 3. And so now we have x to the negative third power. Remember, you cannot have a final solution that has a negative power, so we're going to use our negative power rule and kick that down into the basement. So I will have x to the third in the basement, and since there's nothing left in the numerator, we fill it with a 1. Problem 2. X to the ninth divided by x to the negative fifth. Now, I am always going to recommend that you rewrite these in fraction form. X to the ninth over x to the negative fifth. This will help keep you from making silly mistakes. When you're using fraction form, you will use your quotient rule. Your quotient rule is the opposite of your product rule, so we will subtract the powers. X to the 9 minus negative 5. Well, 9 minus negative 5 is 14. So that leaves us with x to the 14th power. Problem number 3. Negative 3 to the negative second power. Negative 3 to the negative second power. The first thing I'm going to do is apply my negative exponent rule. And so I'm going to kick this whole thing down into the basement. Negative 3 squared. Again, I need a filler in the numerator. Now, generally, I would say apply your power to power rule because the 3 has a power of 1 times its outside power of 2. But really, the only purpose of the parentheses in this particular problem is to help us understand that what's being squared is a negative 3 value. So that would be the same as me saying 1 over negative 3 times negative 3, which is going to be equal to 1 over 9. Problem number 4. Negative 17 squared. Now remember that in this case, the squared value, or the exponent of 2, is only applying to the term in front of it, which is 17. So our final solution is going to keep the negative sign, and we square 17, which is 289. So our final solution then is negative 289. Number 5, negative 6 squared. Well, again, negative 6 squared is the same thing as saying negative 6 times negative 6. Anytime you multiply two negatives, you're going to get a positive. So we really only need to worry about the term. 6 times 6 is 36. Number 6. We start off with 2x to the third raised to the 4th. And to help make sure that we don't make any silly mistakes, we're going to go ahead and remember that 2 is raised to the 1st power. And now we'll apply our power to power rule. And our power to power rule tells us that when we have a power being raised to another power, you multiply the 2 powers together. So we have 2 raised to the 1st power, which is raised to the 4th power. So we multiply 1 times 4 and end up with 2 raised to the 4th power. We also have x raised to the 3rd power raised to the 4th power. So we multiply 3 times 4 and we end up with x raised to the 12th power. Now since we have a numeric term that we can simplify, 2 to the 4th power is 16 x to the 12th power. Scratch that because I wrote it down wrong. Okay, problem number 7. X to the negative 4th, y to the 12th, over x to the 6th, y to the negative 4th. Now we're going to simplify this one step at a time. I'm going to go through each term and either keep it or drop it, depending on what its power does. X to the negative 4th is going to come downstairs so that it can become positive. Y to the 12th can remain upstairs because it's already at a positive power. X to the 6th is a positive power, so it can remain on the bottom. And y to the negative 4th is going to come upstairs so that it can become positive. Well, now we should notice that I can apply my my product rule for both sets, the numerator and the denominator. Y to the 12th times y to the 4th, so we add the powers. Leaves us with y to the 16th over x to the 4th times x to the 6th. So again, we add our powers. X to the 10th power. And we can't simplify those because they have different bases, so that will be our final solution. Number 8. 5 to the 0th power. Well, we talked about in class this being one of our rules. Anything to the 0th power is always 1. So fortunately, anytime you see something to the 0th power, that should be a simple solution. Its value is 1. Number 9, 5x to the 0th power. Now again, we see something being raised to the 0th power, but we need to be very careful to remember that 5 is being raised to the 1st power, x is being raised to the 0th power. So 5 to the 1st power will remain 5 to the 1st power. X to the 0th power will become 1, so we have 5 times 1, which now equals 5.